We're going to continue section 1.5 with quadratic equations. So as I mentioned in my previous video, a quadratic equation has the form ax squared plus bx plus c. Normally we want to have a quadratic equation equal to 0 to solve. So we can either solve a quadratic equation by factoring. So think of other ways you can solve a quadratic equation. So factoring, we can complete the square, and completing the square leads us to the quadratic formula. So we can also use the quadratic formula. So let's try an example. With factoring, so for example, say I have solve x squared plus 8x plus 12 equal to 0. So here, first we want to see, can we factor it? So we go from our study in section 1.3 of factoring. I'm looking for two numbers whose product is 12 and whose sum is 8. So are there two numbers whose product is 12 and whose sum is 8? And yes, the numbers are 6 and 2. So because the leading coefficient is 1, I can go and say this is x plus 6 and x plus 2 equals 0. And now we can use the zero product property. The zero product property says that if I have two numbers, a times b, and they're equal, you multiply them together and they equal 0, what do you know about one of those numbers? Right? In order for two numbers to be multiplied and equal 0, one of them has to be 0. So either a is 0 or b is equal to 0. Now this doesn't work if it's something else, right? Like this, oops, that looks like a b. It does not work if the equation is not equal to 0. If something other than 0. Right? For example, if I had something like x times x plus 2 equals 12, you couldn't say either x is 12 or that x plus 2 is 12 because you can't. In this case, the factors of 12 are, you can even have 12 times 1 is 12, 1 times 12 is 12, 2 times 6 is 12, 6 times 2 is 12, 4 times 3, 3 times 2, and so on. So you can't, or 3 times 4, sorry, and then 2 times 6, I think we already did that one. But you can't say that. The only time that this works is if it's equal to 0, because then you know if you're multiplying two things to equal 0, one of them has to be 0 in order for us to get the product. So here, either x plus 6 is 0 or x plus 2 is 0, which here says x equals minus 6, and this one says x equals minus 2. And so those are our answers, and you can check them. Right? If I'm going to check negative 6. If x equals negative 6, I'm going to have negative 6 squared plus 8 times minus 6 plus 12, and does that give me 0? Negative 6 squared, that's 36. 8 times 6 times negative 6 is negative 48 plus 12, does that equal 0? And follow your order of operations, right? Always do things from left to right. So 36 minus 48, that's negative 12, plus 12, that does equal 0. And so we're good. And you can, I encourage you to check x equals minus 2 and see if that works. So check that on your own. So let's try another example. Say I want to solve 2t squared. Now the variable doesn't have to be always x, so plus 5t equals to minus 3. So it is a quadratic, and notice that I have it equal to something else. I want it to be equal to 0, so we have to first set it equal to 0, which means you're going to add 3 to both sides. Normally you want to align them so that your like terms line up, but here I don't have a constant term on the left, so I'm not going to have it. So I'm going to have 2t squared plus 5t plus 3 equals 0. And now I'm going to try to see, does this factor? So using the AC method that I showed you in section 1.3, I'm looking for two numbers whose product is a times c. Right now that I have it in the standard form, a x squared plus bx plus c. It doesn't have to be x. It can be t, y, w, s. The variable doesn't matter. So 2 times 3 is 6. So two numbers whose product is 6 and whose sum is 5. So can we find two numbers whose product is positive 6 and whose sum is positive 5? And we actually can use the same numbers, 2 and 3. So 2 times 3 is 6, and positive 2 plus 3 is 5. So we go and use the factor by grouping method. So I'm going to have 2t squared, and I'm going to use my numbers that I found, right? Plus 2t plus 3t, and then plus 3 equals 0. Right, we rewrote the 5t term as 2t plus 3t. That's it equals 5t. If this is not making sense, go back and look at our 1.3 videos. And so now I'm going to factor by grouping. I have 4 terms, so let's group the first 2. What do they have in common? They have a 2t, so I'm left with t plus 1. And the second set of 2, what do they have in common? They have a 3, so I take out a 3 and I'm left with t plus 1. And if things factor, this is going to happen. You're going to have a GCF of t plus 1, so, or of the same thing. So I'm going to take out the GCF and I'm left with 2t plus 3. You can also do it by trial and error. You can use any factoring techniques that you learn in your prerequisite class of intermediate algebra. So now here, I use the zero product property, right? I have it equal to 0, so that's good. So I'm going to have t plus 1 equals 0, or 2t plus 3 equals 0. And so I get either t equals minus 1 or t equals, subtract the 3 and divide by 2 minus 3 halves. If both of those work, so when you go back and check them like we did for the previous example, then you can change the or to an and. But they both have to work. And so let's try another example. Say I want to solve, I'm going to change it just slightly. What if I have 2t squared minus 5t plus 4? So instead of being plus 3, is now plus 4 equals 0. And so now, two numbers that multiply to 8 and add up to negative 5, that's not going to work, right? The only factors of 8 are 1 and 8 and 2 times 4. And neither of those, if you adjust the signs with any of those, they don't add up to negative 5. So we're kind of stuck. So you can either complete the square or you can use the quadratic formula. And in this one, we're going to use the quadratic formula. But if you want to review on completing the square, the first example that we did is a good example on to review completing the square. So I'm just going to, let me come back to this one, because I want to review completing the square. So a review of completing the square. So we're going to use our equation above, x squared plus 8x plus 12 equals 0. So when you're completing the square, you only use the variable terms, so the x squared and the 8x. So I'm going to rewrite it, sending the 12 to the other side. So I'm going to have x squared plus 8x, and we're going to leave a gap equals negative 12. And this is the gap for completing the square. So when we complete the square, what do? Do you remember the process? Right, I take the middle term, the 8, we divide it by 2, which is 4, and then I square it. So that's what we add to both sides of our equation. So I'm going to have x squared plus 8x plus 16 equals negative 12. plus 16. So the number that we get after we square, that's what we add to both sides. And now we factor. So the idea is that this is a perfect square. Which perfect square? X plus 4. Right? Two numbers that multiply to 16 and add up to 8 are 4 and 4. And then this is negative 12 plus 16 is 4. And now we use the square root property. Take the square root of both sides. So I'm going to have x plus 4 equals plus or minus the square root of 4, which is 2. So I have x plus 4 equals plus or minus 2. Don't forget about that plus or minus. Anytime you take the square root of something, you get plus or minus. And then subtract 4 from both sides. So x is negative 4 plus or minus 2. And now you split them up. So x is negative 4 plus 2, or x is negative 4 minus 2. So in one, we get x equals negative 2, or x equals negative 6. So going back at the top, notice that that's what we got. X equals negative 6, or x equals negative 2. Now if you complete the square on ax squared plus bx plus c equal to 0, if you complete the square on this, you are going to get the quadratic formula. So what is the quadratic formula? The quadratic formula says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And maybe when we meet in one of our Zoom meetings, I can show you my little story that goes with that. So going back to our other problem, I wanted us to solve 2t squared minus 5t plus 4 equal to 0. Notice that this didn't factor, and completing the square will be a little bit too painful for this. So we're going to use the quadratic formula. So for the quadratic formula, one of the things that I like to do is identify what's my a, what's my b, and what's my c. So a is the coefficient of the square term, so a is 2. B is the coefficient of the linear term, so in this case it's negative 5. And c is the constant term, so in this case the constant term is 4. And now I plug him in. So x is minus b. B is already negative, so minus a minus 5 plus or minus the square root of b squared, so minus 5 squared, minus 4a, a is 2, and c is 4, all over 2a. Make sure you do the whole thing over 2a. You don't want to just do the radical portion, it's the whole thing. So this becomes 5 plus or minus the square root of, simplify the inside here, so that's 25 minus, let's see, 4 times 4, well 4 times 2 is 8, times 4 is 32 over 4. And now here's a red flag. What's wrong with that? I guess I should have highlighted it red. I'm going to have 5 plus or minus the square root of a negative number, right? Negative, what's that? Negative 7 over 4. And I can't take the square root of that. So this is not a real number. So it has no real solution. So we can say that this equation has no real solution. It has an imaginary solution, but no real solution. So later we're going to learn about imaginary numbers, and we're going to be able to simplify this.